Welcome to Mr. Greenstein's Geometry. We're in Chapter 10, talking about circles. We're going to start out with 10.1, lines and segments that intersect circles. So let's just get used to some vocabulary. The center of the circle is the point that is equidistant from all the other points. So this point here, D, is the center, and all the points around the circle are equidistant from that point. The diameter is a segment that goes from one side of the circle to the other through the center. A radius is a segment that starts at the center and goes out to a point, one point on the circle. A chord is any segment that starts on the circle and ends on the circle. So it can start and end on a circle, and that means a diameter is also a chord. A secant is a line that goes through a circle and goes through a circle at 2 points. There are 2 points here, and that's a secant. What's a little different is a tangent. A tangent touches on the circle at one exact point, and that point is called the point of tangency. Tangent circles are coplanar circles that intersect in one point, and they're called tangent. So if I have these circles here, I have 3 circles. I have the orange circle, the green, and the red circle, and they all meet at this one point here, and that is called the point of tangency. So they're coplanar circles that intersect at one point, and they're called tangent circles. Concentric circles are circles that have the same center point. So here I have this circle and I have this circle, and both of them share the same center point, although each one has a different radius. Common tangents are lines that are tangent to 2 coplanar circles. So if I look here, I have a tangent line that's going in tangent to 2 circles, so they're called common. That's called a common tangent. Here I have a line that's going between the circles, and that is also a common tangent because it meets at this one point, the point of tangency. Here's another view of the same sort of thing. Here I have 2 lines that are tangent, and they're going between the circles. The tangent line to circle theorem. So this is a really important theorem. This says that if I have a line of tangency with a circle at point P, then if I draw the radius from the center out to P, I form a right angle with that tangent. So in a plane, a line in a tangent to a circle, or a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at that point. This is a very important theorem because then we can build right triangles with this. Here's another theorem, external tangent congruence theorem. It says that if I have an external point and then I have 2 tangents that are emanating from it to the same circle, say R and T, then these 2 segments are congruent, SR and ST. So let's actually see why this is true. And the way that I can do that is I start out with my circle and my 2 tangents. I'm going to say that R and T are tangent, even though they don't quite look like tangents, but let's just pretend they are. So there's a point of tangency. And then I'm going to draw a line from R to P and from T to P. And I know by the other theorem that says that a radius going out to the tangent is going to form a right angle. So I have a right angle there, and I have a right angle there. And then I'm going to connect P and S. So now I have two triangles. With these two triangles, I can see right away that I have congruent radii, so these are congruent. And I know that this side here, PS, is reflexively congruent between the two triangles. So then I have a right triangle and a right triangle, and I can use HL to say that the two triangles are congruent because the hypotenuse and one of the legs of each one of these right triangles is congruent. Therefore, these two triangles are congruent. And if they're congruent, then all of their parts are congruent. Therefore, ST and SR have to be congruent. So we just proved how those can be congruent. Now I'm going to leave these for you to solve. You can see right away that RS is going to be congruent to RT if the S and T are tangents, which we're going to assume they are. So then you can solve this equation. And then over here, this is a thought problem. What is the angle Q? And we're talking about this angle here. What is the angle Q if the angle P is 42 degrees? And I will leave that to you to figure out. And we'll talk about these things the next time we get in class.